Start with any subset of a metric space. You start with any metric space. The point you take in a metric set is said to be isolated point. If one only. Of set T, if one only. It is not a limit point. That's it. Not a limit point. Understand? Take a point in a set. If it is not in a set, it cannot be isolated point. Take a point which is in an inside.
Sir, sir, sound వస్తుంది మీ దగ్గర నుంచేనా?
Just wait, sir. Is it okay, sir?
No, okay, sir.
So it is not a limit point of a set E. Means whatever point you are going to check whether it is isolated point or not, the point must be in a inside the set. This is my set E. So in order to say that P is isolated point of a set E, it's enough to check that whether it is a limit point or not. If it is not a limit point, automatically it is an isolated point. Limit point, not a limit point means what? You can find at least one neighborhood of P such that that neighborhood should not intersect E other than P itself. That means what? So that means other than P is an empty. If you include P, that is singleton P. We can find at least one neighborhood. The 10 should intersect E at most the point itself. That means it is not a limit point, means that is a definition, right? So let us start with the simplest example. Suppose R with respect to visual metric. You start with any set you take, for example, open 0, 1. What are the isolated points? See, the isolated points which are denoted by I. Set of all isolated points which are denoted by IE. Of set E. Right? So you are asked to find what are the isolated points of set E. Right? So, actually this is my 0, 1. Right? Is it an isolated point? No, because it is a point which is outside of the set. What I'm saying, actually, the point should be in E. When you want to check that is an isolated point, that point should be in set E. So it is an outside of the set, therefore it cannot be isolated point. Is 0 is isolated point? No, because it cannot. If it is 0, 0 does not belongs to set, therefore it cannot be isolated point. Is it isolated point which is inside? No, because a point which is inside is a limit point, because you take in a neighborhood, it contains at least one point other than the point shaded point itself. Therefore, A cannot be isolated point because A is a limit point. Is 1 is a limit point? Is 1 is isolated point? Yes, because you take in a neighborhood, it contains at least one point other than point itself. Therefore, 1 is a limit point. Is it an isolated point? So 1 is a limit point means what? 1 cannot be isolated point. Is it an isolated point? You take any right side to 1, any point which is right side to 1. Is it an isolated point? The answer no, because it cannot be a point of the set E. So what are the set of all isolated points of E? Empty. Yes or no? Is it clear? Hello?
Yes, sir.
Yes. Right. నేను ఫాస్ట్ అయినప్పుడు కొంచెం చెప్పండి, మెసేజ్ చేయండి, ఓకే? ఎందుకంటే కొంతమంది ఫాస్ట్ చెప్తే కొంచెం ప్రాబ్లం అవుతున్నట్టున్నది. మెసేజ్ చేయండి. With the same metric, suppose I can take 1 by n such that n belongs to n. What are the isolated points? You are asked to find what are the isolated points, right? So this is nothing but 1, 1 by 2, 1 by 3. It's a decreasing sequence going on. Question is that there is a 0, but 0 does not belong to set. Question is that which you take any point which is less than 0, is it isolated point? No, because which is not in E, therefore not isolated point. Right? Is it isolated point which is right side to 1? Is it isolated point? No, because it does not belong to set E. Therefore, it cannot be isolated point. Points which are right side to 1 cannot be isolated point. Is 1 as an isolated point? Is 1 is an isolated point? Yes, because I can find a very small neighborhood, teeny neighborhood, which contains only 1 itself. I can suppose I can choose right 3 by 4. Suppose you can take this is 4 by 3. It is a neighborhood of 1. Already I told you any bounded interval, open bounded interval can be treated as a neighborhood. This is a neighborhood. 3 by 4, 4 by 3 is a neighborhood. In this neighborhood, does it contain any point other than 1? No, contains only singleton 1. Understand? In this neighborhood, only 1 is there. What is the intersection of this neighborhood and with A? Only 1. Therefore, there is at least one neighborhood which intersects the set E at most about the point itself. Therefore, 1 is a point of E, and there is a neighborhood which intersects the set itself at only the point itself. Therefore, 1 cannot be a limit point. Hence, that means if you delete y minus 1, it is an empty. That means what? There is at least one neighborhood which never intersects the set E other than 1 itself. Therefore, 1 cannot be a limit point. Hence, 1 is a isolated point of a set E. Is it clear? Because 1 cannot be a limit point. Is it a isolated point? Is it isolated point? No, because they are the point. This is a point. This does not belong to set E. Therefore, it cannot be isolated point. Is 1 is an isolated 1 by 2 is an isolated point? 1 by 2 is an isolated? Yes, because it is not a limit point. Because I can find at least one neighborhood which does not contain the point itself, other than the point itself. If 1 by 2 neighborhood lo 1 by 2 ఒకటే ఉంది. Therefore, 1 by 2 cannot be limit point, but 1 by 2 belongs to set E. Therefore, it is an isolated point. Is 1 by 3? Yes. Is 1 by 4? Yes. Is 0? No. Because 0,
because it is a limit point.
in fact, it does not belong to set E. Therefore, it cannot be limit point. Okay. So, what are my isolated points of E? What are my isolated points of E? E only. Every point you take, that is an isolated. Is it clear? Is it clear?
Yes.
Suppose you take this, I can adjoin 0, can add 0 with respect to visual metric. What are isolated points? What are isolated points?
Itself.
Itself, the point which are in itself, right? 1 is an isolated point, yes, because 1 is not a limit point. We find a neighborhood which never intersects city. Is 1 by 2 is an isolated point? Yes, because I can find very small neighborhood which never intersects city. Is 1 is an isolated point? Yes, because I find some neighborhood which never intersects the city other than 1 by 3. Therefore, 1 by 3 is not a limit point, hence it is a isolated point. If 0 is a isolated point, 0 belongs to set E, but 0 cannot be isolated point because 0 is a limit point. You give me any neighborhood, it contains at least 1 point other than the point itself by Archimedean property. Yesterday I told you. So what are the isolated points? 0 cannot be isolated point, and a point which is less than 0 also isolated point because it does not belong to set. So what are isolated points?
1 by 2 1 by 3.
Going on. That means set of all 1 by n such that n belongs to. Right? Suppose I can take the same argument. Suppose I can take any finite set like this. 1, 2, 3 with respect to visual metric. What are isolated points? Anybody? What are isolated points?
E అవుతుంది సార్.
Yeah, E itself. E itself, good. Because this is an isolated point, we can draw at least one neighborhood which intersects the set itself only at a point. Therefore, 1 cannot be limit point. Hence, isolated points are 1. Is 2 is isolated point? Yes. మనం వేరే పాయింట్స్ గురించి అవసరం లేదు, సెట్లో ఉన్న పాయింట్సే మనకు అవసరం. చెప్పాను కదా, సెట్లో పాయింట్స్ లేని అవసరం. They cannot be isolated. Is it isolated point? Yes, because it cannot be limit point. Because I can find at least one neighbor which never intersects at E other than 2 itself. Therefore, 2 cannot be limit point means 2 is an isolated point. Is 3 is isolated point? Yes, because we can find at least one neighborhood which never intersects at E other than T itself. Therefore, 3 cannot be limit point. It is an isolated point. That means set itself. Right? Suppose you can take E equals to rationals. What are the isolated points? What are the isolated points? Anybody? What are the isolated points?
Q అవుతుంది సార్.
Q, sir.
Q? Guess Q? Is it Q? No, right?
Yes, sir.
Because no, right? If you take any rational, is it isolated point? No, because you take any neighborhood, it contains at least one rational other than this itself, other than A itself. Therefore, A is a limit point. Yes or no? A is a limit point of E. Why? Because any neighbor you draw around A, it contains at least one point other than A. Therefore, A is a limit point means A cannot be isolated point. Is it clear? So what are my isolated points?
Empty sets.
Empty sets. Good.
ఇక్కడ లిమిట్ పాయింట్స్ క్యూనే సార్.
Limit points are, sir, are. Every real number is
Ah.
real. Every real number is a limit point.
కాబట్టి అన్ని లిమిట్ పాయింట్స్ ఉన్నాయి కాబట్టి ఐసోలేటెడ్ పాయింట్స్ లేవు కాబట్టి ఎంటీ సెట్.
Empty sets. Empty set. Next is suppose you can take not general గా మీకు వచ్చే ఎగ్జామ్ లో వచ్చే క్వశ్చన్స్ అన్ని గుర్తుపెట్టుకోండి. ఆర్ మీన్ అని వస్తాయి, లేకపోతే R2 మీన్ అని వస్తాయి, RN మీన్ అని వస్తాయి. అందుకే మీరు ఎక్కువ ప్రాక్టీస్ చేసేది R2 మీద ప్రాక్టీస్ చేయాలి, RN మీద ప్రాక్టీస్ చేయాలి, యూజువల్ మెట్రిక్ మీద ప్రాక్టీస్ చేయాలి, డిస్క్రీట్ మెట్రిక్ మీద ప్రాక్టీస్ చేయాలి. అందుకే మోస్ట్ ఆఫ్ ద ఎగ్జాంపుల్స్ నేను అవే తీసుకుంటున్నాను. ఎందుకంటే క్వశ్చన్ పేపర్స్ లో అవే ఉంటున్నాయి కాబట్టి మనం ప్రాక్టీస్ చేసే క్వశ్చన్స్ కూడా ఆ రకంగానే ఉండాలి. ఇది క్లియర్. సో R2, R3, RN, యూజువల్ మెట్రిక్, రైట్? సో D2 తీసుకున్నారు అనుకోండి, D2 మీన్స్ యూజువల్ మెట్రిక్, దట్ మీన్స్ యూక్లిడియన్ మెట్రిక్, దట్ మీన్స్ యూక్లిడియన్ డిస్టెన్స్. మీరు ఏ క్వశ్చన్ పేపర్ అనేది తీసుకోండి, D2, D ఇన్ఫినిటీ ఇవే వస్తాయి. ఏ క్వశ్చన్ పేపర్ అనేది తీసుకోండి, అందులో క్వశ్చన్ ఉందంటే ఇవే ఉంటాయి. సో లెట్ us start with a simplest example. Suppose you take any set of all order pairs such that you take any condition you take, you know, y equals to x square parabola, right? Suppose you take this y equals to x square. Question is that what are the isolated points? What are the isolated points? Anybody? What are the isolated points? What are the isolated points? No, right? No point is isolated point, right? Because you take any neighborhood, it contains at least one point other than the point itself. Therefore, this is a limit point. Is it a limit point? Because yes, it is a limit point. Why? Because you take any neighborhood, it contains at least one point other than the point itself. Therefore, every point is a limit point. Every point of the set is a limit point, right? So therefore, none of the points are isolated points. Is it clear? Hello?
Clear, sir.
Right. Suppose you can take any example. See, let us start with the simplest examples. Suppose now to such that x is 0, x is 0. That means what? X is 0 means what? X is 0 means what? This y-axis. Question is that what are the isolated points? What are the isolated points?
Empty sets.
Empty sets. That's okay. I hope you understand. If you take the same idea in D infinity, means maximum of mod xi yi such that I equals to 1 to 2. Question is that in R2, L infinity metric. Suppose the same strategy, if you take x comma y, set of all order pairs such that x plus y equals to 1. It's a line equation, right? It is a line equation, right? Question is that what are the isolated points? What are the isolated points? Anybody?
Empty set.
Empty, good. Because you take any point here. What is my neighborhood here? What is my neighborhood? Open square. Open square. You take any open square around this point, it contains at least one point other than the point itself. Therefore, this point is a limit point. Is it a point a limit point? Is it a point limit point? Yes. Because you take any open square, open sphere, open square, sorry, it contains at least one red point other than black point. So black point is a limit point. If you take this point, is it a limit point? Yes. Because you take any open square around this, contains at least one red point other than black point. Therefore, black point is a limit point. So what you observe, every point is limit point. Therefore, isolate is empty. Is it clear? Right. So next concept is closure of the set. You have seen interior of a set and derived sets and isolated sets. Right. Next is closure of the set. You start with any metric space. Any metric space you start. You take any subset of a metric space. The closure of the set is denoted by like this, right, which is defined by E union derived set of E. Right? This is a definition. E union derived set of E. Right? It can be true for in topology also. This is a definition. So this is what is my definition? E union derived set of E. That's what my definition. Right? So suppose you can take an example R with respect to usual for understanding purpose. Start with simplest example. So what is a closure? You are asked to find what is a closure of the set. What is a closure of the set? What is the closure of the set? Anyone? What is the closure of the set?
Close interval 0, comma.
Close
Right.
interval.
Right. So my set is actually open 0, 1. Right. So what is the closure definition? Closure definition in E union derived set of E. Right. So E is nothing but as it is open 0, 1. I don't know derived set, but derived set is nothing but what? 0 is a limit point. This point is inside points also limit point. 1 also limit point. Therefore, what are my limit points? Close 0, 1. Therefore, my closure of the set is interval 0, 1. Closed interval 0, 1. Suppose you can take any set you like this. You take like this. What is the closure of the set? What is the closure of the set?
Same set.
Hmm?
Same set.
Same set.
E.
Same set. Because 0 is a limit point, including 0, lying between 0 and also 1 also limit point. 1 also limit point. Therefore, close 0, 1, that is itself. Right? Suppose you can take rationals. Rationals. What is the closure? What is the closure? You know, every real number is a limit point. You know, what is Q? What is E? E union derived set. What is the derived set of Q? So any real number you take, it contains at least one rational other than the point itself. Therefore, R. Right? So what is my derived set? R. Therefore, Q union R is equals to R. Therefore, E closure is equals to R itself. Suppose you can take 1 by n. What is my closure? E union. What is my derived set of 1 by n? Already told you 0 is the only limit point. So what is the closure? What is the closure?
1 by n union 0.
0.
Singleton.
Suppose you can take 1 by n plus 1 by m such that n comma n over n. What is the closure of the set? What is the closure of the set? What is the closure of the set? Anybody? You know, this is a very standard 0. Right, good. Because you fix m first of all, you fix m, you know, as fix m means what? 1 by m is fixed. 1 by m is fixed. Right? So therefore, this tends to 1 by m as n tends to infinity. Therefore, this sequence converges to 1 by m. Therefore, any limit of a sequence always limit point of a sequence. Therefore, 1 by m is always a limit point of a sequence. Because this is true for every m. This is true for every n. If you take m equals to 1, therefore 1 plus 1 by m converges to 1 by 1. If you take m equals to 2, 1 plus 1 by n plus 1 by 2 converges to 1 by 2. Right? Therefore, these are my limit points. Union. Again, you vary both you vary as n comma n tends to infinity. Therefore, this tends to 0. Therefore, what is my limit point? 0 is also limit point by Archimedean property, of course. Median law. 0 is a limit point of the set. Right? So what is my set itself? Set is 1 by n plus 1 by m such that n comma m belongs to n. That means what is my closure? This is my closure. This is set with union limit points. Right? Is it clear? Is it clear? Hello?
Okay, sir.
Okay. Right. Suppose you can take R with respect to discrete. So take, for example, open 0, 1, simplest example. So what is the closure of the set? Anybody? What is the closure of the set? E union derived set. What is my derived set?
Closed
You know,
interval.
Closed
derived,
interval 0, comma.
what is my derived set?
Closed interval 0.
0.
None of the points are limit points, right? Therefore, 0 cannot be limit point because I can adjust a neighborhood as a singleton 0. Does not contain other point. Therefore, 0 is not cannot be limit point. Is it a limit point? No, because I can adjust a singleton as a neighborhood. This does not contain any point other than the point itself. Therefore, this point is not a limit point. This point also not limit point. This point also not in. This point also not limit point. This point also not limit point. So none of the points are limit points. So therefore, this is open 0, 1. That is set itself. Is it clear? None of the points with respect to discrete are limit points of the set. In fact, every point of the set is an isolated point. Is it clear? Hello, is it clear, Amma?
Yes, sir.
Suppose you can take, for understanding purpose, you take 1 by n over n belongs to n. What is my closure of the set with respect to discrete? Anyone? What is the closure of the set? Anyone? E itself, right? Because derived set is empty, right? The answer is 1, E itself, right? Because derived set is empty. Because derived set with respect to discrete is empty. Therefore, E only. Right? Next, properties of closure. Right? First property is you take any metric space, and you take any subset of A. Closure of the set is always the smallest closure superset of A. That means, in fact, you need to write as it has also definition before that. Means intersection of all closure supersets of A. Each one is closed. Intersection. This is my definition. Actually, this is a definition of topology. Closure of the set is intersection of all closure supersets of A. Each F is closed, which is a superset of A. Second one is E-closure is the closed set. Not only closed set is the smallest closure superset of smallest closed superset of E. Means this is the smallest. This is very smallest among all closure supersets of E. Wait, what is the interior of a set? Interior of A is the largest open subset of E. That's what I am telling you before the class, yesterday class. Right? Interior of a set is the largest open subset of E. You need to mention it. Understand, interior of A is the largest open subset. Is the largest open subset of E. Whereas closure of the set is the smallest closure superset of E. and E is closed. E is closed. I already told you what is the definition. E contains all its limit points. Of course, there is another strategy. The closure of the set is itself. Whenever E is closed, if and only if, no need to write, no need to find the closure. It is same as saying that E itself. Whenever E is closed, E closure is itself. E closure is set itself, right? And E closure, whole closure is nothing but E closure itself, right? E closure, because E closure is a, already told you, E closure is nothing but a closed. E closure is nothing but a closed. When you take, it is a closed set, the closure is itself. The closure is itself by property 3. Property 3. Is it clear? Hello? Hello?
Yes, sir.
Okay, sir.
Yes. So closure of you take any closure set, you take any closed set, closure of the set is itself. This is very, very important property. Or else you can take any example also for understanding purpose. You take R with respect to usual. Right? You take any closed interval 0, 1. What is the closure of the set? You know it is a closed set because it contains all its limit points. What is the closure of the set? What is the closure of the set? You know, is it closed or not? Yes. Is it closed or not? Because it contains all its limit points, no? This is a limit point. This belongs to 0. This 0 belongs to set. This also belongs to set and it's the limit point. This also belongs to set and it is a limit point. 1 also belongs to the set and it is a limit point. Therefore, every limit point is a member of the set. So therefore, it is closed set. So whenever it is closed set by this property number 3, E closure is itself. No need to find it in the union derived set of E. That is a time waste. Whenever E is a closed set, closure of the set is itself. Whenever E is open set, what is interior of a set E? E itself. Understand? You need to mention what is it. What I told you actually is open if and only if interior of a set is itself. Interior of a set is itself. Whenever E is closed, closure of the set is itself. Right? And fifth is E intersection F. Whenever E and F are close, whenever E and F are subsets of X, the closure of this is nothing but a closure of this intersection with closure of this. It's a proper again. Right? So converse may not be true. You can directly do it. You can take open 0, 1, right? F is equals to open 1, 2 in R with respect to usual metric, right? If you take what is the closure actually? What is the closure of E? Closed interval 0, 1. What is closure of F? What is closure of F? Anybody? What is the closure of F? Closed interval 1. So this intersection with this. What is this intersection with this? 0, 1, 1 to 2. What is this intersection? Is 1, 2. What is the intersection of? Intersection with 0 to 1, 1 to 2 means what? It's an empty. This closure is empty. Closure is empty itself, right? Therefore, empty cannot be this. You know, E closure intersection F is empty. Empty not equals to E closure intersection F closure. Therefore, this is a proper may not be equal. This is a proper may not be equal. Yes or no? Is it clear? Hello?
Yes, sir. Clear.
Okay. Again, is that actually again this is true for only finite collection only. You can given by any counter example. You can take any counter example. You take 1s1 by n plus 1 by n. This is true for only finite collection. You can take an example also. You can take an example also. Right. Next is property number 6. This union F closure is nothing but E closure union F closure. Whenever E and F are subsets of X. Right? This also important property. You can check it, see, by using by straight away definition. But the thing is, again, my notice is actually this is true for only finite collection, but not infinite collection. You take again any singleton R, R with respect to usual, R with respect to singleton. You take any R is a rational, right? What is union of this over Q is nothing but rationals. The closure of this is nothing but closure of this. Closure of this is nothing but R. But the closure of this, union of the closure is nothing but union of the union of singleton R closure. Singleton R closure is itself, because singleton R is a closed set, because it's a finite set. Finite set closure is, you know that it's a finite set is always closed. Closure of the closed set is always itself. But union of singleton over Q is nothing but Q itself. You know that these both are not same. Therefore, this union can be true for only finite collection, need not be true for infinite collection, means arbitrary collection. Is it clear? Hello? Yes or no? Hello?
Okay.
Yes, sir.
Next is, right? Perfect set means what? You start with again any metric space. You start with any subset of X. Is perfect. Perfect. If and only if every point of a set E is a limit point of a set, and means derived set is itself, set itself. Derived set is nothing but what? Itself. Derived set of a set is its set itself. So can you give me at least one example?
Closed interval 0, 1.
Yeah, closed interval 0, 1 with respect to visual metric. That is important. Metric is important, right? Because what are my limit points? My limit points are nothing but set itself, because every point is a limit point. Is a limit point, is a limit point, is a limit point, one is a limit point. These are not limit point, these are not limit point. So the only limit points are the points of the set. Therefore, this is 0, 1. Therefore, set T itself. Therefore, it's a perfect set. Suppose you can take singleton 1. Is it perfect set? Anybody?
No, sir, with respect to visual metric.
No, because what is a derived set? Already told you, finite set has no limit points. It's an empty. It cannot be, finite set is a closed set. Finite set has no limit points. Therefore, derived set is empty. Therefore, it cannot be singleton. It cannot be E itself. Therefore, it's not perfect. Not perfect. Right? Suppose you can take 1 over n. Is it perfect? Is it perfect?
No, no, sir.
Then no, because my derived set is 1 over n such that n over n union singleton 0, it cannot be U itself, therefore it's not perfect. If you add the 0, again it is a perfect. That is a different matter. Right? Take R with respect to discrete. Right? If you take E equals to same thing, suppose close 0, 1. Is it perfect? Is it perfect? No, right? Because derived set is empty, it cannot be,
Empty.
right? It is not perfect. Yes or no? Because derived set is empty. None of the points are limit points. Therefore, derived set is empty. Therefore, it cannot be E. Right? Suppose R square with respect to T2. Suppose my set is xy such that x is less than 1. Yeah. Is it a perfect set? Student Nepal actually. Student Nepal. Is it perfect set? No, like this. This is like this. X equals to 1. Left side to this.
All left side is.
Right. Is it a limit point? Well, a
Yes.
point on this one. Is it a limit point? Yes. Because you take in a neighborhood contains at least one point which is left side to line. Therefore,
Yes.
limit point. Is it a limit point? Yes.
Yes.
Is it a limit point? Yes. Is it a limit point? Yes. But the thing is, the points on the line are members of the set E. The
Less than
points
or
of
equal to.
right. So derived set is nothing but what? Set of all
X
points
less than or equal
x
to
like
1.
this. But this cannot be in E, because the points on line are not belongs to set E. Therefore, it's not perfect. Is it clear? Hello.
Yes, sir.
Yes, sir. Understood.
Next is dense. You start with any matrix space. E subset of X is dense in X if and only if the closure of the set is full space. The closure of the set is full space. Yes or no? The closure of the set is full space. That is the definition. Right? Now tell me, suppose I am giving you, take any set you take. Suppose you take 0, 1, open 0, 1. Is it dense in X?
No.
No, because the closure is closed interval 0, 1. It cannot be full R. It cannot be full R. Therefore, not dense. Not dense in R. Suppose if you take closed 0, closed 1. Is it dense in R?
No.
No, because the closure is itself, because a closed set cannot be R. Therefore, it's not dense in R. Suppose you could take 1 over n such that n over e is union 0. Is it dense in R?
No.
No, because the closed set, closure is itself, it cannot be R. Not dense. Because the closed set, closure of the set is itself, it cannot be R. Therefore, not dense. Therefore, not dense. Suppose I can take E equals to Q. Is it dense?
Yes.
Yes, because E closure is nothing but what? E union derived set of E. That means R. That is nothing but R. Therefore, closure of the set is R. Therefore, E is the only dense. That means Q is dense in R. Now, can you give me another example? Dense, rational number, irrational numbers also dense. Because the closure of the set is what? R minus Q. What are the limit points of irrational numbers? R. Because every real number is a limit point of irrationals. Because every real number you take in a neighborhood it contains at least one irrational other than A itself. Therefore, every real number is a limit point. So, what is my derived set of irrationals? R. Therefore, what is the closure? E itself. So, I think these are the only two which are dense in R with respect to visual metric. Clear? Hello?
Yes, sir.
Yes,
Okay,
sir.
sir.
Suppose you can take another example. Suppose my set is this x equals to 1 to set of all other pairs such that x so y equals to x. Is it dense?
No.
No, because it's a closed set. The closure of the set is itself. Therefore, it cannot be R2. Not dense. Suppose if I take x is a rational, is it dense? Is it dense?
Yes, sir.
Yes.
Yes, yes.
Yes, sir.
Yes, because you take any. See, what are my limit points actually? First of all, set itself union with see every order pair you take any open sphere, it contains at least one rational first coordinate. Understand? R comma y, R comma yes, this R is a rational number, this R is a rational number. So any neighborhood you can take that contains at least one point in which first component is rational. Therefore, every order pair is a limit point of the set. Therefore, this is nothing but what? R square. Therefore, R square union, this means what? R square. Therefore, E is dense in R2. Is it clear? Is it clear? Suppose you can take this set of all rationals, set of all order pairs as that X belongs to Z only. Is it dense in R2?
No.
No?
No, sir.
No. This is 1, 2, 3. This is -1, -2, minus. Is it dense? No, because this is a limit point. Yes, is it a limit point? No, right? Is it a limit point? No, right? Is it clear? So this cannot be a limit point. I can find a neighborhood which never intersect the set E. Therefore, the closure cannot be. What are my limit points? First of all, what are my limit points? What are my limit points? Only points which are on which are on these lines, which are on these lines. Yes or no? The points which are on only these lines. Is it clear? Because this is a point which limit point. Because any neighborhood talk, it contains at least one point other than the point itself. Therefore, it is also limit point because you take in a neighborhood contains at least one point other than itself. Therefore, it is also limit point. Is it a limit point? Yes, because you take in a neighborhood, it contains at least one point other than itself. Therefore, what are my limit points? The set itself. Therefore, E, but this cannot be auto. Is it clear? Hello, is it clear, Amma?
Okay, sir.
Yes, sir.
Yes. Suppose you can take this same strategy, but I can extend this idea. Suppose I can take X is integer, Y is also integer. Is it dense in R? Is
No,
it
no,
dense
sir.
in R? No, the same strategy, right? Boxes. Right? This is my actually figure. This is 1, this is 1, 2, 0, -1, -2. What are my limit points first? What are my limit points? E itself. E only. E only. Every point of the set is a limit point. Yes or no? Yes. What are my actually limit points? E only. Therefore, E is nothing but E itself. Is it clear? The same strategy which works.
Yes,
Yes.
yes, sir.
Right. Next is separable space. So before that, bounded. Bounded. Yeah. Give me definition of bounded. Give me definition of bounded.
Having a lower and upper bounds.
Yeah, that is with respect to visual metric, right? That is with respect to visual metric. But what is the definition of bounded means in general in metric space? A set is said to be bounded in a metric space. It should be in some open ball. It should be in X. If or only it should be in some open ball center at A with radius R. For some A, for some center, for some radius. For some center, for some radius. Is it clear? So that means if it E should be, see, this is my actually metric space. This is my set actually. When you want to say it is a bounded, you need to show that E should be in some open ball center at A with radius some R. E is inside some ball. That means E inside some open ball or some open neighborhood. Is it clear? Definition? Is it clear? Definition? Yes. Suppose go through some example with respect to visual metric. Right? To take E equals to, the simplest example is 1 over n such that n over n belongs to n. Is it bounded? Is it bounded?
Yes,
Yes,
sir.
sir.
Yes. In general, this is a real analysis course because R with respect to visual metric. So what is my upper bound? 1.
Bound is 1.
What is my upper bound?
1.
1. What is the lower bound? 0.
0.
But according to this idea, how can you express this? You know, this -1 is actually less than 0. If -1 less than 1 less than or equals to 1, therefore this can be rewritten as 1 less than 2. This can be written as -2 less than -1. Therefore, -1 by n belongs to -2, 2. This is true for every n. Therefore, 1 by 2 belongs to the ball center at 0, 2 radius. This is true for every n. That means you give me any member in the set. Give me any member in the set which is contained in the some ball center at 0 with radius 2, because the ball center at 0 with radius 2 in usual metric is exactly precisely -2, 2. This is both are same because the ball center at 0, 2 are nothing but what? Set of all real numbers such that whose distance from 0 is less than 2. That means what? -2 less than x less than 2. That means what? Open interval -2 to 2. Therefore, 1 by n sitting inside in the ball centered 0 with radius 2. This is true for every member in the set. Therefore, every member in the set which is inside the ball, therefore, this is contained in the ball centered 0, 2. Therefore, according to this definition, it is bounded in this matrix space. Is it clear? Definition? Is it clear?
Not clear.
Okay.
One more time.
One more. So what is the basic idea is, the basic definition is, whenever you want to show it is bounded, you need to show that it should be in some open ball. That's the definition. Some open ball, not every open ball, or some open ball. Right? So, this is a basic idea, in basic analysis, this is a 0 is a lower bound, 1 is an upper bound. Is it true? Is it okay?
Okay.
Yes. Right? So, can it be written as like this? -1 less than 2, less than 0? Yes. Can it be written as, see, actually -2 అనే కాదమ్మా, ఇక్కడ నేను ఏమైనా తీసుకోవచ్చు, బట్ ఫర్ సేక్ ఆఫ్ అవర్ కన్వీనియన్స్ నేను -2 అని తీసుకున్నాను, కానీ మీరు -3/2 అని తీసుకున్నా ప్రూఫ్ వచ్చేస్తుంది 3/2, because I need to find an open ball. So -3/2 less than 1 by n less than 3/2. That means what? 1 by n belongs to this open interval -3/2 to +3/2. This is true for every n. That means what? What are the members in E? My set 1 by n's. So any 1 by n is in the open bound interval. But what is this open bound interval? Ball centered 0, ball centered 0 with radius 3/2 in geometry. Therefore, 1 by n belongs to the ball centered 0, 3/2. This is true for every member which is in n. That means every member you take in the set that is inside the ball. That is inside the ball. Therefore, E is contained in the ball centered 0, 3/2. Yes or no? మీరు ఏదైనా ఇవ్వండి 1 by n ఎక్కడ ఉంటుంది? బాల్లో ఉంటుంది. Therefore, what that is inside the ball, therefore it is closed. Is it clear?
Okay, sir.
So therefore, suppose I'm going to take another example. For example, ఇట్లా ఇచ్చాను అనుకోండి, సేమ్ యూజువల్ మెట్రిక్ తీసుకోండి అండర్స్టాండింగ్ కోసం, ఎందుకంటే ఇది మీకు బాగా తెలుసు కాబట్టి. దెన్ ఐ కెన్ ఎక్స్టెండ్ ద ఐడియా ఫర్దర్ మ్యాటర్. సపోజ్ నేను 0, 1 ఇచ్చానమ్మా. ఇజ్ ఇట్ బౌండెడ్ అంటే జనరల్ గా ఇది బౌండెడ్ అనే చెప్పాలి, ఇక మళ్ళీ చెప్పాల్సిన అవసరం లేదు. ఇది కంటెంట్ ఇన్ సమ్ ఓపెన్ బాల్ అని చెప్పాల్సిన అవసరం లేదు. బట్ ఎట్లా యూజ్ చేయాలని డెఫినేషన్ చెప్తున్నాను, కానీ యూజువల్ మెట్రిక్ ఇస్తే మీరు పెద్ద చెక్ చేయాల్సిన అవసరం లేదు, ఎందుకంటే లోవర్ బౌండ్ అప్పర్ బౌండ్ ఉంది కాబట్టి ఆటోమేటిక్ గా బౌండెడ్. ఎస్ ఆర్ నో?
Yes, sir.
బట్ ద థింగ్ ఈస్ ఇన్ దిస్ కోర్స్ ఎట్లా చెప్పాలంటే, యాక్చువల్గా యూ నీడ్ టు గో త్రూ లైక్ దిస్. సో ఎనీ మెంబర్ యూ టేక్ దట్ ఈస్ ఇన్సైడ్ 0, 1. ఎస్ ఆర్ నో? Any member you take in the set, that is inside 0, 1. But this can be written as like this: -1 less than 0. Therefore, x should be -1 plus 1 should be in every point in the set. Therefore, every E should be in -1, plus 1. But -1, plus 1 can be written as the ball center 0, 1 in usual. Therefore, E is inside some open ball. Yes or no? Because this is my open 0, 1. I can inside some open ball like this. This is my open ball centered 0 with radius. This is my open ball. This is my open ball. So this is my set. This is my set. This set is inside the red region. What is the red region? It's an open ball. Red region is open ball. This is my open ball. So this is my set. My set is inside the open ball. మీరు ఇట్లా కూడా తీసుకోవచ్చు, -2 to +2 కూడా తీసుకోవచ్చు, ప్రాబ్లం లేదు. This is at least one open ball ఉంటే చాలు. The set is inside at least one open ball. Of course, -100 to +100 తీసుకున్న ప్రాబ్లం లేదు. Yes or no? Therefore, it is bounded. Is it clear?
Okay, sir.
Suppose I can take this example. Yeah, tell me. Suppose I can take E equals to natural numbers. See, thing is, first you need to go through the usual lemma, and because in usual, what happens? Is it bounded?
No.
No, because it is a lower bound, not upper bound. Barkhounian property, it is not bounded. Barkhounian property, it is not bounded. Right? But the thing is, you take integers. Is it bounded? No. By the same property, not bounded. Suppose I'm going to take, I'm replacing this metric by usual, discrete. Suppose I'm going to replace this metric by discrete. Question is that if you take a natural numbers, counting numbers, is it bounded? The answer, yes. Because, already I told you, E can be written as, suppose I can take like this. What is my open ball? Can you give me? What is my open ball? Suppose, any ball, center one or 100, something else, right? Radius is 2. What is my open ball? Anybody? Center 100. Suppose center 100. Radius 2. What is my open ball with respect to discrete? Anybody? Anybody? What is my open ball? Center 100. Radius 2. With respect to discrete. Anybody?
1, 0, sir. Set 1, 0.
1 comma?
1, 0.
Is it my open ball? No, right?
Singleton A.
Singleton one only.
Singleton A.
Singleton
No.
one only.
No, right? Because it is, it is 2 bigger than 1. My open ball is full R. Understand? What is my open ball? Center take on 1 with respect to discrete. Whenever R is bigger than 1, it is full R. It is singletons. Whenever R is less than or equals to 1. Go through your basics. So therefore, this whenever R is radius is bigger than R, it is full R. Wherever radius is less than or equals to 1, singletons. So my radius is what? Here 2. My radius is what? Actually here 2. So therefore, it is bigger than 1. So my open ball is full R. Full R contains natural numbers. This is nothing by my set. That means E is inside the ball, some ball centered 100 with radius 2. E is inside some open ball centered 100 with radius 2. Therefore, it is bounded in discrete. Discrete. Is it clear? Hello?
Sir, one second explain.
Okay.
Okay. Suppose, give me set first of all. You take some integers. Okay. Give me any set. Question is that can you give me open ball? Can you give me any open ball which is contain given set? If that happens, that is bounded. Can you give me some open ball? Does it contain E? Can you give me some A? Can you give me some A? Can you give me some R? Yes, the answer is because I can give A equals to 2022. R is equals to some 3. So what is my open ball? A
Just
comma
R.
R only. R.
2022 3. That means R. This R contains integers. Yes or no? This R contains integers. Yes or no? Yes. But what is my integers? E. Therefore, E is inside some open bar. E is inside some open bar. Therefore, this integers is bounded. I hope you understand in discrete. Okay. Is that clear? Hello?
Yes.
Any doubts?
No, sir.
Suppose you can take any set, previous sets. For sake of convenience, this is my set. Question is that, is it bounded? Is it bounded?
No, sir.
No, right? No, right? You give me any open ball should not contain full line. Yes or no? Yes or no? My open ball is nothing but what?
Open
My-
circle.
Open circle. Does open circle contains this full line? No. Yes or no? మీరు ఇంకా బిగ్ తీసుకున్నారనుకోండి ఈ అవుట్ సైడ్ పాయింట్స్ అవుట్ సైడ్ ఉండిపోతాయి. ఎసాను ఇంకా బిగ్ తీసుకున్నారనుకోండి ఈ అవుట్ సైడ్ పాయింట్స్ ఉంటాయా సెట్లో, బాల్లో ఉంటాయా ఈ పాయింట్స్? నేను ఇంకా బిగ్ తీసుకుంటాను సార్. మీరు ఎంత బిగ్ తీసుకున్నా బై ఆర్కోడైమ్ ప్రాపర్టీ ఇట్స్ ఫెయిల్స్. ఈ పాయింట్స్ అవుట్ సైడ్ ఉండిపోతాయి. సో ఎనీ ఓపెన్ బాల్ విచ్ డస్ నాట్ కంటైన్ ద సెట్ దెర్ఫోర్ నాట్ బౌండెడ్. ఇస్ ఇట్ క్లియర్? మీరు ఒక బాల్లో లైన్ ఇన్సైడ్ చేస్తారమ్మా మొత్తం లైన్ని. క్వశ్చన్ ఏంటంటే
No, sir. No.
బాల్లో మీరు జామెట్రికల్ గా ఆలోచించాలి. బాల్లో ఈ లైన్స్ ని ఇన్సైడ్ చేస్తారా మొత్తం? నో, ఇట్స్ నాట్ పాసిబుల్. సో దెర్ఫోర్ నాట్ బౌండెడ్. ఇదే ప్రాబ్లం నేను కొంచెం డిఫరెంట్ ఇచ్చాను అనుకోండి. x square plus y square equals to 1. Is it bounded? Is it bounded?
Bounded, sir.
Bounded because I can adjust some open ball with center 0, radius 2. This open ball is nothing but what? Open circle, center at 0 with radius 2, which contains your circle. Yes or no?
Yes.
Yes. Therefore, S is inside some open ball, hence it is bounded. Is it clear? Is it clear? Hello? All of you, మీకు అర్థమైతే నేను ముందడుగు పోతాను.
Yes, sir.
Suppose I can take R2 such that mod x plus mod y less than 1. Or else, yeah, you can take this. Okay. Is it bounded?
Yes, sir.
Is it? Yes, because
Yes,
actually what? Actually what?
Rhombus.
Rhombus, open rhombus. So my radius is, suppose I can take 2 radius, or you can take 3 radius, nothing wrong. My center is 0 itself. This open ball contains S. Therefore S is bounded. Suppose ఇదే ప్రాబ్లమ్ ని నేను r with respect d infinity ఇచ్చాను అనుకోండి. In this metric space is S is bounded? Yes or no? In this metric space R2 with respect to d infinity with the same set is a set in R2. Is it bounded? అర్థమైందా క్వశ్చన్? Set of all order pairs mod x plus mod y less than 1. నేనేమి ఇచ్చాను? R2 with respect to d infinity. ఈ మెట్రిక్ స్పేస్ లో ఈ S అనే సెట్ బౌండెడ్ అవుతుందా? Is it bounded in R2 with respect to L infinity metric? The answer yes, right? The answer is yes, because this is my set actually. నేను బాల్ ఏమి ఇస్తానంటే యాక్చువల్గా రేడియస్ 2 ఇస్తాను. ఇది యాక్చువల్ ఏంటి? ఓపెన్ బాల్, ఇట్స్ అన్ ఓపెన్ స్పియర్, సెంటర్ ఎట్ 0 0, రేడియస్ 2. Center at 0 0, radius of diagonal radius is 2. Therefore, this open ball, this is my open ball here. This is my open ball. This is my open ball. This is my open ball. This red open ball contains your given set. Contains your given set. Yes or no? Is it clear?
Yes, sir.
Yes. So therefore, it is bounded. Right? Is it clear? Suppose my set is set of all order pairs such that right of plane x positive. Is it bounded? Is it bounded?
No, sir, unbounded.
Unbounded. Right? Is it bounded in R infinity? The answer? No. Because can you plug this right of plane in some open sphere? Some open sphere means rhombus. Sorry, this is my not fair. You can take. So can you insert this right of plane in some open rhombus? No? Yes or no?
Outside
Very-
points will be there.
యా, మీరు ఏది ఇచ్చినా అవుట్ సైడ్ పాయింట్స్ ఉండవు. ఎంత పెద్దగా ఇచ్చినా రేడియస్ రైట్ సైడ్ అవసరం ఏమైతుంది ఆటోమేటిక్గా ఉండిపోవు అనమాట. దెర్ఫోర్ ఇట్ ఇస్ నాట్ బౌండెడ్. Is it clear? Okay. So with this basic arguments, basic analysis of arguments are completed. Any doubts? Doubts?
వినబడుతుంది కదా అందరికి అయితే?
Yes, sir.
Yeah.
Okay, sir.
A series, a1 x minus x naught, a2 x minus x naught square, like this, a series of this form we can call as the power series. Okay,